Welcome everyone to the 2020 APAC Groundbreakers Virtual Tour by APAC UC. This year our event will be the biggest one ever done. 174 sessions including normal sessions, workshops and hands-on labs from 122 different speakers over 11 days. Also, it will cover sessions on 4 different languages. Please remember to register to as many sessions you can, and all sessions will be available to replay as many times as you want for 2 weeks after the initial session date and time. You can also interact with the speaker at any time during the 2 weeks by posting questions or comments directly in the playback session in the session page in the Hey Summit webinar. I would like to say thanks to all Oracle user groups and Java user groups that made this event possible, and also to our sponsors, Oracle Groundbreakers and CloudDB. Now for today's sessions, Reactive Streams processing using a Java library, Helidon and microservices by Pablo Silberkasten. Feel free to write questions anytime during the session, and also in the session page after it is played for you. You can interact with the speaker for 2 weeks, just basically writing your questions and comments, and the speaker will respond to you in that page. Now, without any more delays, I would like to leave you with this amazing session by Pablo Silberkasten. Thank you.
Okay. Good night, good evening, everybody. What we are going to talk about today is a Java library that we are shipping now in November with the next release in 21C. So here is the agenda of what we are going to talk about. We are going to talk about the challenges when you're streaming data into the Oracle database. We are going to talk about this library that we built to address those challenges. We're going to talk about the API of the library and see some code samples of the library and how we integrate it with another frameworks. We're going to show how to use the library Helidon, talk a little bit about Helidon also, which is Oracle's response for microservices. And then we are going to do a little demo of this microservice. We're going to do all these tests with the Oracle Cloud. So what are the challenges when streaming data into the database? Basically, it's a high concurrency. When you have multiple tens of thousands of concurrent clients working, trying to insert records into the same table in the same database, that wouldn't scale. When you have also this huge amount of customers, they fight each other from resources for the database. So that this is the problem that the library addresses. Also the responsiveness. I mean, when you are inserting records into the database, there is with the blocking driver, then even if you are using batch inserts, right? There is a blocking moment when you are sending all the records to the database, and sometimes that part of being blocked is something that is not acceptable, that you have to build something to do it asynchronously or to do it in a separate thread. So the library does that for you out of the box. You don't need to create something specifically to do it on the background. And also elasticity, right? To be able to grow or shrink the allocation of resources in the demand. This is what we are thinking, what the final thought about this. One database is not going to be able to handle thousands of concurrent live connections, or will be very affected by performance. So in the cases where you're trying to do that, SQL inserting statements is not going to be acceptable for this solution. Another thing that the library addresses, and it's a very common problem, is to provide an abstraction layer that will allow you, for example, use features that are in the database, and then you need to code them in your program. The library does that for you. And most important, when something happening in the background topology, right? If you have multiple nodes, or if you have a sharded database in the background, you need to build the mechanisms to know about these changes in the topology, or to use sharding keys if you're using a sharded database. So the library does that for you also out of the box. And this is the conclusion, that is very challenges that to provide all these features without changing the customer, right? So the idea of having this abstraction layer between your program and the database allows you to explore all these features from the library. Don't pay attention to the new in 20C, it's new in 21C, because 20C is going to be a 21C is going to be a long-term support, right? So that's why we are shipping it in 21C and not in 20. So what is the library? By the way, it's going to be in OTN for you to download, and also in Maven. So it's going to be a Java library. That is the important conclusion. It's not a product, it's not something, it's not a service, it's a Java library that you download and use. That's why it's shown here in the context of a Java program. So what are the features of the Java, of the RSI library? First of all, provide a streaming capability, right? To be able to stream records into the database without blocking. Second, it allows you to group the records to not only improve performance by grouping them and using batch streaming, but also to route depending on the topology, right? If a node in a rack database is down, then the records are going to be redirected to the node that are still up, or the same thing with the shard. If it's going to look at your records and it's going to point to the specific shard that you're using. Optimizes CPU allocation because it decouples the record processing from the I/O with the database. And the secret sauce of the library is that it uses direct path insert, which is a method to insert records into the Oracle database that is the most performant of all, and I'm going to explain why. Basically, when you're using direct path, instead of going to the conventional path where you send a SQL command, the buffer starts to be full, then also you need to create queues, full the buffer cache, and eventually create database blocks that eventually are reading into the database. When you use direct path, what you only do is to get a new portion of the database where you are going to write records and then adjust. After you write them, it's going to adjust what is the higher watermark when this record was inserted, right? So basically, what you're doing with direct path is writing directly into the database files instead of going through all this processing, right? So this makes it very quickly because the only thing that you're doing is I/O with the file system, and you are not using all these processes in the middle. And it's not only faster because of this, but also because you are not competing with other processes that might be using the database for all of this, right? So that's why it's so fast. Going back to the things that we were talking earlier, the more features of the library, what we were saying, to recognize shard keys and to reuse connections that is going to use to a specific shard. And in rack, again, getting to know if the load balancing advisory is like if node in the rack database has a higher consumption, higher usage than the other one, is going to receive the fun event and is going to act accordingly. But let's jump into the code. So this is basically the simplest case of how to insert records. So let me go to a simple record, to a simple example in here. Let's use a simple submission publisher. So the way you use this is you create a library by using a URL where your database is going to be, a username, a password, a schema, a worker thread pool, because if you don't use anything, if you don't send this value, then the library is going to create a thread pool for you, but you can create one of your own. Then use a size of how many rows do you want to. I'm changing this because I see below that I'm going to insert 3. So I don't want to block the library while it's doing the insertion. So buffer rows is how many records is the maximum amount of records that it's going to hold before flushing into the database. The buffer interval is the same, but in second. What is the maximum amount of time that is going to wait before insertions? And then, but let me show the simplest case would be simple push publisher. This is going to be easy. You can use now for building, you can use this solution. Then what is the table and the columns that you're going to map, and then you just instantiate the publisher. Now we are going to talk about a different API, but the push publisher is just to send records, and that's it. And then you CF-read, and that's it. I mean, it's as simple as that. This few lines of code to execute it. This database is down, so I'm going to show you with this other project, a simple flow publisher. No, let's show the simple submission publisher. I should tell you about the submission publisher before doing this example. Let's run this, and then I will talk to you about the submission publisher. So let's go to my cloud database. Oh, another thing. So you see here that in my connection, I'm telling where my wallet is, which is in target wallet. So basically, when you're working with a cloud database, if you go to transaction processing, that's my database. See that you can download the wallet. If you download the wallet, it's going to be a zip file. I don't know what I want to show you now. But what you gotta do is to then expand this wallet in here, and then the connection is going to be as simple as to make a reference to where your wallet is, and then use your user and password. But let's go. One thing. When you use, when you configure the library, you can tell what is the class that you're going to use for mapping, and then in the class you tell what is the table that is going to point, and what are the columns that you're going to map. If you don't put any in the annotation, if you don't tell the column name, it's going to use the name of the. Okay. So let's see our database. What is this? let's look at this table. This is user 1. And the table, again, the table we see is customers. So there are no records. So we are going to execute this simple submission publisher. The library is taking all the topology, is creating the pool, and now it's starting to check. Obviously, for this scenario of only 3 records is not useful, right? The idea is that you use it for millions of records, right? But let's see. These 3 records were inserted by using it. But let's talk a little bit about the Flow API and the submission publisher and the push publisher. So the push publisher, like I was telling you, is something that is very simple. It's you create a publisher, then you hook it with the library using this, and then you just use the accept, and that's it. There is no more than that. So then you can insert it by using a string, or then you can use also flux. I can show you the reactive stream. This sample, I think, is a flux. Let's create this table so you believe that this is working. Table is truncated, and I think I have the reactor push annotation. So basically what I'm doing here is the same, right? I'm pointing to the same database, I'm setting an interval, and then I was showing how to do it with table and columns and how to do it just with an entity, right? Then you create a push publisher, and then you can either insert it like it was in here, just sending customers, or in this case, using Flux. Flux is a reactor, it's a Spring library that allows you to work with reactive streams. So what you say is, okay, just these records, then concat, add more records, and then do something when it's finished, do something if it's canceled, and then at the end subscribe with a consumer, which in our case is the push publisher, right? So running this, reactor push annotation. The done here is this one, because when everything, I mean, this is reactive, right? You see on complete, do this, right? So complete is showed done. And the records will be set. But now going back to, okay, this is for the reducing with the reactor. Here, if you are interested in looking at it, you can go to this URL and you can see. So what is the Flow API? This is definitely something that if you haven't seen before, you can investigate. It's the Flow API is a new API added in Java 9. Basically provides interfaces for you to use, right? And the interfaces are publishes, subscription, and subscriber. In this interaction, the library is the subscriber, of course, right? It's the one that is receiving the record. And what you do is you create a publisher that is going to subscribe to the library, and it's going to build a subscription that you also gotta provide, that is going to make a relationship between the library and your publisher. The way that this works is that the library, when it has, when there are records that still can be, when the library has the buffer still available to receive records, it's going to say request, but it's going to signal the publisher that it's okay to send more records, right? So that is the idea of to show that there is an unsatisfied demand, and then you can send more records, right? So this is an example of how to create a publisher. You create the subscriber, you create the subscription, then you got to override. What do you do because the interface, the publisher, you got to override subscribe. So the only thing you do is to make the association and to call the event. And then you gotta say what to do in accept. This accept comes from consumer, and obviously what you gotta do when you're accepting a record is to send the record to the library in the method of next. Then if we look at the subscription, what you gotta do is, okay, when you are being called request, is the library telling you that it can accept more records, right? So you can, you can log it, you can update a counter, you can do many things in here, right? It will depend up to you. And obviously, the ingestion is going to happen when the publisher accepts a record. Let's see, this is, we already saw how to use, if you don't want to create your, let's see first the flow, and then we'll talk about this a little bit. So let me show you a simple flow publisher. This is what I was showing you in this example. First of all, let's clean the database. So when you create a flow publisher, this is the publisher that I created, a super simple publisher, what I was showing you in the Excel, just to make association for the subscriber, and then on the accept, call the subscriber, calling the on next, that is going to be the ingestion of the record. And then the subscription, I also create something super simple that the only thing is going to show that the library is telling the publisher that can ingest more records, right? That the library is saying, okay, send me more records that I can do, right? So you're going to see, we're going to run this example with two publishers pointing to the same library, and we are going to insert these 6 records. And you're going to see the library saying, okay, I can get more records. That's something that you don't have with the push publisher. You have it only with the flow, right? The flow telling you, okay, give me more records. So here is the library telling, this is what's in here. And there you have the 6 records that we were talking about. So going back to the presentation. Let's say that you don't want to get all these issues with that you don't want to create all these classes, then you can just use the submission publisher, which is out of the box from the SDK, and then you can use as simple as submit. This was the first sample that I showed you. Using a submission publisher, that if you look at it, it comes from the JDK. Right? It's part of the JDK. And then you can use this instead of building your own implementation. So the important conclusion that we can have from here is you can either use this submission publisher from the JDK, you can create your own flow publisher, implementing all this stuff. You can use third-party libraries like this one, or you can use just a push publisher that is going to do only accepting records. What is the problem with using the push publisher? against using the flow publisher. Let me show you one very important example. If you use the push publisher, and we are going to send 3 records. If you say that your buffer is only going to be 2, so the push publisher, when the buffer is full, the only thing it can do is to raise an error because it doesn't know what to do, right? So if you say, okay, 2 records, and we send 3 records before flashing, it's going to run an exception because the buffer is full. See? Notify memory pressure, and the only thing it can do is cancel. The cancel is in here because there was an exception, and there is nothing else it can do. On the other hand, if you have a flow publisher, let's use the submission publisher, and let's do the same. Let's put 2. Since the submission publisher is seeing that the library is saying, okay, don't send me more records, it's going to withhold. The submit is going to do nothing. It's going to wait for the library to signal that there are more records to be executed. Right? So instead of getting an exception when you run it like that, it's going to wait, and eventually it's going to do the ingestion. So that is the importance. See, there was no exception and the records were ingested. I didn't truncate, so there are many records. Stuff before. But you know the point, right? That when you are using the push publisher, you have no feedback, so there is nothing that the library can do. But when you use flow, then it knows the publisher knows that it has stopped before sending more records. Okay, let's keep going. So the general idea for the library is to run in a higher environment, right? This is not a product. This is something that we were working on, and this is the demo that we're going to show, is to use the library, exposing different protocols, and then ingest records into the database, right? What we're going to see in today's demo is this one, to create a REST engine that is going to accept records using JSON, and then it's going to ingest into the database. We also have a demo for gRPC and AMQP. What are the features that this provides? Again, this is not a product, it's something that you gotta build. It's better performance, responsiveness, have multiple protocols. What is Helidon? This is not our presentation, but it's something that if you want to investigate, I think it's very good. It's an Oracle response for microservices using Java. You can use the Helidon MP, that is just the higher libraries that you can use, for example, for JSON processes, for dependency injection, all other stuff. And then you have SE, that is more low-level things that you can do with that. This is just a reference. It's also out of the spectrum of this presentation, but it's explaining what is Docker and Kubernetes. I guess most of you already know what it is. And this is how we are going to do our demo in a higher level, is that we publish the image, we have it running in OKE, and then it's going to call the cloud database, and then we are going to run some records in here to ingest into the database. So let's do the demo. The demo, eventually, this is what we are going to do. We are going to have the library. We are going to expose with Helidon the records, and we are going to use JMeter to insert into the database. And if you want to contact me, here is my phone number, my GitHub, and my mail. And there is no, if there is a session survey, please fill it. But let's go to the code. Enough with presentations. So I have this demo that is here, which is the library instead of a Helidon project. If you start to look at Helidon, oh, again, here I have my target, the same thing that I did in the other one. I have my wallet as part of the project. So if you look at Helidon, the whole thing ends up being a service, right? And in a service, you're telling, okay, these are my paths and the method of my HTTP that is going to do, and then what to do for each one of them, right? I created an RSI library that then I'm going to use in a flow publisher and in a push publisher, right? That I'm going to use. And if you look at the accept, what it's going to get is to get the request, it's going to parse the JSON payload, and then it's going to send it to the database. So let's truncate the table. I think it's already truncated. Oh, but actually, what we are going to do is to this table, to the device reading them. We are not going to do into the customer. So let's see if we have something in there. Nothing to display. So let's first start locally and see what happens. So my microservice is starting, and it's also starting the library. And there you go. So when up and ready, listening here. So let's see that this is running. Up and running, okay. So let's start to send records. So see here that I'm going to send to localhost to accept. Then I'm going to send this record, right? So I send it, and you see that the response is immediately, right? There is no latency. This is the important part, that it's not, the response time is immediately. It's not like a SQL insert that you might need to wait for the database to answer, right? But let's send these 3 records. That might be, remember that the library flashes record every 20 seconds. I mean, it depends on the configuration. In my configuration, I sent a default. I didn't say, no, the buffer interval is 10 seconds. So it might be a lot there, but it's more than 10 seconds, so it's probably already there. And then you can see there the 3 records that I just sent through code, right? So that is pretty cool. But I think it's even cooler if we deploy this into the Oracle Cloud, right? So the interesting thing is I have here my project. I won't show this because we wouldn't have time, but you can see that there is a Docker file that is just built in my library. There is no, it's as simple as that, creating the Docker file. And then you can deploy this into OKE. To deploy this into OKE, let me show you the console. I have this cluster that I created. This is very simple, that I created to get to deploy my image here, right? And you can see the node pools, for example, and you see pool 1, and you're going to see the 3 nodes in here, all of these. And you can also check it out from using the OCCI. So you can see There is some lag indicator. Okay, but these are the free nodes that are in my cluster. And then to deploy the image into the cloud, it's as simple as using a YAML. I can show you the YAML I use for this. Let's see here. The only thing you say, okay, this is my application, the image that I created, and then create a service that is going to be listening in the port 80, and then it's going to forward the port to my application, right? So I deploy here, and then I already deploy. It's very quickly the deploy, but even so, I already did it before the demo, and then you can see the services that we are going to check the external IP. Right? So there is a load balancer that is listening in this port. So you can do two things. First of all, you can check the same thing here. You see that it's running, and you can also DB, okay, it will tell you something about the database. But let's insert records, right? So first of all, let's truncate this. So you believe me. And now, instead of pointing to localhost, let's point to my deployed service. And again, it's not found out because I put a double. There you go. So again, the same thing, but now it's sending to my deployment in the cloud, right? And you also see that the throughput is very, very good. And let's see. Okay. You see already on these records. And finally, we can do a test with JMeter. That it was part of the demo to show how to send multiple records. And that the performance, even with high concurrency, is very good. So what I'm going to do here is to create 20 concurrent threads that are going to send records, these records to my service. I gotta change the IP for my service. That's it. Now let's see the performance of running this. And you see also that even with concurrent, the response time is in double digits, right? It's very low there. And the throughput is very high. You can see these are the different payloads. It's creating random data, right, to send to the database. Let it run a little bit more. And we can stop it and then see all the insertions. Then you can see here all the random data that was being inserted and the performance. And the point is, if you want to do the same thing by just doing insert with multiple concurrent customers, then the performance is not going to be that good. And we can check that actually, because I told you that the service, if you use accept, it's going to use RSI, but if you use insert, it's going to do an insert into. So let's put insert instead of accept to see what happens to this number. Let's see what happens. See that the performance is not as good. There are a lot of 3 digits in the response. Performance is not as good. And this is with a few amount of records. If you use even higher, it's going to be. So anyway, thank you so much for your time. Please reach out if you need any questions and stuff. I'm looking forward to see you. Thank you. Bye-bye.